Hello and welcome back to Precalculus, section 4.3 on right triangle trigonometry, and then we will follow with 4.2, right, which is on unit circle, which is also trigonometry of the unit circle. So we'll be defining this from two different angles, I guess. Now, we are all familiar, hopefully, with the right triangle, which triangles have, right, three angles and three sides. And for the right triangle, we have Pythagorean Theorem, which is one of the formulas that we might know from the past, where a squared plus b squared is equal to c squared. Now, we also might know that the a and b sides are called legs, the shorter sides. So leg and a leg. And the longest side is called the hypotenuse. And we are also, in addition to this, we are also going to use two more words here. The leg that it's touching the angle theta will be called the adjacent. And the one that it's not touching the angle is going to be called opposite. So opposite side, adjacent side, and then hypotenuse will stay hypotenuse because it has the unique name anyway. So now we can define these trigonometric values, which are actually ratios of the sides. So when I write sine theta is equal to b over c, which is actually opposite over hypotenuse, you see that the sine value is equal to the ratio, division, of the two lengths that you have, b divided by c. Now, b is always shorter than c because c is defined as the longest side in the triangle. And this ratio will always be smaller than 1. Right? So this will always be smaller than 1. Well, it could be 1, right? It could be 1. But it's always going to be smaller or equal to 1 because b is always less than c. Or they could be equal, but again, that's to produce 1. Now, what are we actually after? Actually, you know what? We'll come back to this idea later than 1 and blah blah. When I'll deal with domain and range and other things later. So we'll come back to that. So what is sine theta? Sine theta is the ratio between length b divided by length c, and those you can measure if you have a measuring tape or a ruler, right, with divisions. You can just go and measure the lengths and just divide them. Then we have cosine theta, and the cosine theta is going to be adjacent divided by hypotenuse. And we have 6 of these now. Tangent theta is going to be opposite divided by adjacent. And then we have opposite of sine is a cosecant theta, which will be c over b which is hypotenuse divided by opposite. And then we have the secant theta, which is going to be hypotenuse divided by the adjacent. And finally, we have the cotangent theta, which is adjacent over opposite, so A over B, and that's opposite. There you go. Cool. So that's the 6 trigonometric functions defined, right, as the ratios of sides. Now, how does this work? Well, we are going to think about a very special triangle that will have the, well, actually, let's first take a look at an example of this before we go any further and talk about special triangles and things like that. So let's say this is your angle theta. Theta is the Greek letter that looks like that, theta, and usually we use it for angles. While we have this class, we will have alpha, beta, gamma, maybe delta, we'll have pi, maybe we get to see phi. Like, all of these are Greek letters, and alpha, beta, gamma are the first 3 of the alphabet. Alpha is A, beta is B, gamma is G, and delta is D. Those are the ways. It follows. It's closer to Cyrillic than to Latin, which is why you perceive letters being out of order, and me, who's originating from Serbia, right? For me, that's the correct order of letters. A, B, V, G, right? D, and so on. So it's interesting. Anyway, so when you look at the triangle, I can have this side, let's say, as 3, this side as 4, and I want to see all 6 trig functions written. They're not really trig functions, they're trig expressions. You have to have an x in order for it to be a function. All right, so cool. You want to write your sine of angle theta, but you don't have the hypotenuse yet, because you know that that's going to be opposite over hypotenuse by what we had earlier. Well, you have to find your hypotenuse, and you can do that using the Pythagorean theorem, because c is equal to square root of a squared plus b squared. So in our case, that's going to be square root of 3 squared plus 4 squared, and it works out to be 5, right? 3 squared is 9 plus 16. 9 plus 16 is 25. Square root of 25 is 5. So I can write my sine theta as the opposite, which is 3, divided by hypotenuse, which is 5. So sine theta for this triangle is 3/5, right? 0.6. Now we leave it as a fraction, obviously, because it's easier to reconstruct the triangle back, because you know the exact lengths that were used. Right? 0.6 you can make with 6 and 10 as well, right? But when you see 3 and 5, you know that the physical lengths of these sides are actually 3 and 5. So it's better to leave it as a fraction. Cosine theta is adjacent over hypotenuse, and that's going to be 4 over 5. tangent theta is opposite over adjacent, and that's going to be 3 over 4. Now, what else we have? We have a cosecant theta. Actually, you know what? I'm going to move these so that I can fit the other ones next to them. So how about we go right there and then just go next to them, because the cosecant is the flip of sine. Cosecant theta has to be 5 over 3. Secant theta has to be 5 over 4. And cotangent theta has to be 4 over 3. Because those three are just flips. That's how we define them up there, right? When we did this red writing here, we said that the cosecant is a flip of sine. Now, all of those come in play later, right? We're not going to see all of the stuff immediately because there is a lot to set up. So now we have used these to come up with these trigonometric values, and now I know that the cosine of theta for this particular triangle is 4/5. So now we are able to set up, right? We're able to set up these values. Some students like to remember and memorize acronyms because that helps them remember these. You will be setting these triangles up many times. Actually, today in Calc 1, we had, let me see, where's the Tuesday, Thursday class? There we go. Derivative, here, this one. See? There it is. Exactly what we are talking right now, and I used the sine opposite over hypotenuse and set it up, and then we did stuff with it. It doesn't matter. But today you are learning this, and yes, you don't have functions on each one of the sides, you have numbers. You have to start somewhere and then eventually build it up. So what we are learning is actually what we are going to use later a lot, right? So please make sure you can all understand this and ask questions if you have any. So we can have anything, any numbers, and you can always use Pythagorean theorem to figure out the missing side. So if I have now the triangle that, let's say, stands like this, and this is 62, and this is, let's say, 12, and this is unknown, and let's say the angle is here. We don't care what configuration the triangle is in. What we care about is where is that right angle, and we care where is the theta angle, because it could be in any of the other two spots. Once you know where those two angles are, you can immediately say, okay, this is the short side opposite to the angle. This is my longest side, which is hypotenuse. And this has to be my adjacent side, and I don't know the length of that adjacent side. Let me use Pythagorean theorem to figure it out immediately. Pythagorean theorem, a squared plus b squared equals c squared. These are legs. This is the hypotenuse. So you know that you are missing one of the legs. It doesn't matter whether it's a or b, right? You will have 12 squared plus the unknown equals to 62 squared. So your job is to really systematically, right, go around the triangle, say this is what I have, this is what I need, and assigning these is not whatever, it is exactly, right, as I said, opposite of the angle. So the leg that is not touching the angle becomes the opposite side. The another leg that it's touching the angle is the adjacent, and then the longest side in the triangle is the hypotenuse, and longest side is always across the street from the right angle. So now when you have this, you can quickly compute the value for uh, for this. So b is equal to square root of 62 squared minus 12 squared. So you can punch that in a calculator. So 62 squared minus 12 squared is square root of 3700. And now we do the square root of that, and we get 60.8. 60.8. So now we can set up our trig expressions. See, you should not be memorizing, oh, the triangle is this way, so I put this length and that length. And no, right? It is, you are remembering opposite, adjacent, hypotenuse. Um, and, oh, there is that acronym. I'll explain this. But some people remember SOHCAHTOA, and then you can see the sine, and then opposite, and hypotenuse, and the cosine, adjacent, hypotenuse, tangent, opposite, adjacent. The other three are flips. So if you know the basic three, right, you know the other three because they're all flips. So I think this is also in your books somewhere. They have this. So a lot of students like the SOHCAHTOA acronym, and it can be used, right? So sine of theta is opposite over hypotenuse. That's the OH. Opposite, well, that's 12, and then hypotenuse is 62. Now that can be, in this case, can be simplified by 2, and you get 6 over 31. Cool. Then you have your cosine theta, which is, as you can see in the acronym, cosine is adjacent over hypotenuse. Well, adjacent, we just calculated, is 60.8 and 62, and that cancels to 30.4 over 31. Tangent theta will be the last one in the acronym here. Its opposite, in our case, is 12, divided by adjacent, which is 60.8. That cancels by 2 down to 6 over 30.4. Oh, that can actually cancel by 4. Nice. Cancel by 4 into 3 and then 15.2. Nice. And now for the other ones, you just do the flips. So cosecant theta is going to be 31 over 6. Secant theta is going to be 31 over 30.4 because they're just flips. And the cotangent theta is a flip of tangent, which is 15.2 divided by 3. And there you have it. All 6 trigonometric expressions written for this triangle. So if you like the SOHCAHTOA, right, you are welcome to use it as you go around the triangle. All right. So those are our basics, right? Those are our basics, guys. You have your right triangles, and always two shorter sides are called legs, and it doesn't matter which one you label A, which one you label B, because only one of them will be touching the angle, and that's going to be adjacent. So we only care about adjacent, opposite, hypotenuse. We don't care about ABC, because ABC you can put on any triangle in any order you want. But when you have a right triangle, only one of the legs, only one of the shorter sides is touching the angle. And obviously one of the three sides is the longest side, which will be your hypotenuse. That's the name, hypotenuse. So now we'll take a look at those special triangles. I mean, they're right triangles. They just have special values. So if we draw an isosceles triangle, which is a right isosceles triangle, isosceles means, right, that the two lengths are the same. So I have to go, in this case, 4 in each, and then it would perfectly cut through. What you have over here is that your angle is 45 degrees, which is pi over 4. Right? So that's a 45 degrees. I'll write here that the 45 degrees is equal to pi over 4 radians. Now, if you put these lengths to be 1 and 1, then by Pythagorean theorem, the hypotenuse will be root 2. And now, you can write that your sine of 45 degrees, or better, sine of pi over 4, is actually 1 over root 2, because you have your adjacent side over here, you have your opposite side over here, and you have your hypotenuse side over here. 1, 2, 3. So when I do my opposite over hypotenuse, that's 1 divided by root 2. Now, we don't like root 2 in denominator, so we're going to rationalize this and get root 2 over 2. So what I've learned in this case is that sine of 45 degrees, which is also known as sine of pi over 4, is actually square root of 2 over 2. That's a value. That's a number. So now I know how much sine of 45 is, or sine pi over 4 radians, which is awesome. We see that the cosine is going to have the same value because it involves the same numbers, like 1 and root 2. So the cosine is going to have the same value, cosine of 45, and it's going to be square root of 2 divided by 2. And now we can figure out also how much is my tangent of 45 degrees, which is tangent of pi over 4 radians. That's the same, right? And what I have is 1 divided by 1, which is 1. Which leaves me with a cotangent of 45, which is immediate flip. It's also 1. And finally, when we flip the secant and cosecant, so cosecant 45 is equal to cosecant pi over 4. That's going to be root 2. If I go back to this calculation before I rationalize, right here, before I rationalize, and I flip it, right? Because it's the sine is opposite over hypotenuse, and the cosecant is hypotenuse over opposite. So that's going to be root 2 divided by 1. So that's why it's a root 2. And the secant of 45 is also the same way because you're flipping the other function, which has the same values. Is the secant of pi over 4, which is also root 2. So we figured out a couple of these values, which is really, really cool. Now we know how much sine, cosine, now we know all of them for 45-degree angle. Now what other angles are there that we care about? Well, we said that there is angle of 0, there is angle of 30 degrees, 45, 60, and 90. Those are the angles that we care about because those are very easy to compute. Now they will be hiding in another triangle. This triangle is only for, right, because as you can see, this is a 45 degrees triangle, and if this is 90, right, then the other angle has to also be 45, because the sum of all angles on a triangle on a flat surface has to be 180 degrees, with the emphasis on the flat surface. Because if you draw triangles on a curved surfaces, like a top of the ball, for instance, yeah, your angles do not add to 180. So yeah, we have to make sure that when you're adding your angle, you're adding on the flat surface, because on the flat surface, right, the angles of every triangle add to 180. As soon as you move the triangle off of the flat surface and paste it on any kind of curvature, convex or concave, doesn't really matter, you are going to get different answers for sum of all angles. But in our case, because we are on a flat surface, we have 45 plus 90 is 180. And that's how we know that the other angle that is not written is also 45. Now that leads us to a second important triangle. And this one will have 60 degrees there, 30 degrees here, and your 90, because 60 plus 30 is 90, right? And you have that. So now the values that you guys have, the shortest side is 1, the hypotenuse is 2, and then this one ends up being root 3 by Pythagorean theorem. So now, if you want to write your sine of 30 degrees, which is sine of pi over 6, we said earlier, you have opposite. Oh, I didn't mark that. So if I'm using 30 degrees, then this is my opposite, and this is my adjacent, and this is my hypotenuse, always the longest side. So sine of 30 degrees is sine of pi over 6 radians, and that is going to be what? Opposite, which is 1, divided by hypotenuse, which is 2. How cool is that? Now we know that sine of 30 degrees is 1/2. So that's the piece of information that you memorize. Cosine 30 degrees, which is also cosine of pi over 6, is root 3 over 2, because it's adjacent divided by the hypotenuse. And because of that, right, we have root 3 now. Tangent of 30 degrees, which is actually tangent of pi over 6, is what? Anyone?
1 over square root of 3.
Perfect. And then we have to rationalize. So it works out to be root 3 over 3. We don't like roots in denominator. Well, roots of the numbers we can't take the root of. And now maybe it's the fastest if I just go with the cotangent, because that's flip of a tangent. It's just root 3. And then the cosecant 30 degrees, which is cosecant pi over 6. Oh, I forgot to put cotangent pi over 6 is root 3. There we go. So cosecant of pi over 6 is, well, cosecant is the flip of which one?
Secant.
Nope. Cosecant is the flip of sine. Yeah, sine. We'll have some formulas that will help with that later. So when I flip the sine, I just get 2. And finally, I have secant of 30 degrees, which is secant of pi over 6. And that's going to be the flip of this one, right, which is 2 over root 3. And then we rationalize to get 2 root 3 over 3. So here are your values for this one. And you know what? I'm just going to label all of these. Maybe I can put in the middle, actually. Better. I'm going to label this with red dots. Because now, when I switch to blue and use the 60 as my angle, then this opposite becomes adjacent. And this adjacent becomes opposite because my angle has changed. But hypotenuse remains where it is, because hypotenuse is the longest side of the triangle. Right? And if you change the perspective from which you look at a triangle, well, that one is still the longest side. It remains in its place, right, as a hypotenuse, where the other two flip. So now, what do we have? How much is sine of 60 degrees, or also known as sine of pi over 3? And if you take a look at your opposite, which is root 3 divided by hypotenuse, you have root 3 over 2. Then, question of the cosine 60 degrees, which is sine of pi over 3. Oops. Can anyone tell me that? Cosine? Use the adjacent and blah, blah, blah.
Is it 1 over 2?
Very good. Very good. 102. And how about the tangent of 60 degrees?
That's square root of 3?
Yes. And then we have the cotangent of 60 degrees, which is pi over 3. What is the cotangent? Always go back to cotangent is a flip of tangent, so any luck? Come on.
If it can't be 1 over square root of 3, so it has to be, what is that? Square root of 3 over, oh, yeah.
Yeah, it's the same, right? And then we have the cosecant 60 degrees, which is cosecant pi over 3, which is 2 root 3 over 3. And finally, secant of 60 degrees, which is secant of pi over 3, which is the flip of cosine, which is 2. So I hope that you will be connecting the blue dots to the blue writing and understand that your triangle can be flipped in any way. Could be sideways, could be up, going up, or whatever. And as long as you know where your right angle is, as long as you know which angle you are focusing on, right? Not the right angle, but the other theta angle, you should be able to use the SOHCAHTOA, right? The sine is opposite over hypotenuse and so on. You should be able to set up all of these functions very, very quickly. And now,
Are we supposed to know that the blue and then how it matches up to the red?
well, that was my next question.
All right.
So I was about to say, and you already seen it, that all of the values are the same, right? They're just backwards, right? If you take a look, and I try to hide it, right, to write one higher than the other so they don't match up. So let's go into this peanut over here. Do you see that sine and cosine just flipped the values?
Yeah.
Yeah. And then next peanut. Right? They're just flipped. And the final peanut over here. So from this observation and the fact that 90 minus 30 is 60 or 90 minus 60 is 30, we have these what are called cofunction formulas that help us understand the situation we have up there. Sine theta is equal to cosine of 90 degrees minus theta. And tangent theta is equal to the cotangent of 90 minus theta. And finally, secant theta is equal to cosecant of 90 minus theta, because they are producing the same values. Now, we only showed that for this one. Actually, no, we showed them for all. What am I talking about? See, they swap the values. Here's your cotangent, for instance. And maybe I should circle actually cotangent and tangent at the same time. There we go. So tangent of 60 is root 3, and the cotangent of 30 is root 3. That's a very interesting observation. And then we have the other functions. The cosine theta is equal to the sine of 90 degrees minus theta. You have them for all, right? And the cotangent theta is tangent 90 minus theta. And finally, cosecant theta is equal to secant of 90 degrees minus theta. Now, those 90 degrees might have as well been pi over 2, right? So these are the cofunction formulas. And, they can be useful here and there. They're not too frequent, though. Oh, yeah. You will definitely have homework, right, that relates to these. Well, the only thing that it's left, guys, is to talk a little bit about this application. With this much knowledge of trig, you are already able to calculate heights of objects. And I'm talking buildings, trees, flagpoles, everything that you really can stretch the measuring tape to. And the word problems here are all about measuring the sides, and technically some comparison, like a proportion problems. So let's take a look at application. So let's say you want to figure out how tall is a tree. So here's Mother Earth. Then we're going to put a tree over here. There we go. And let's have it orange, doesn't matter. So there's a tree. And now we're going to take a look at the tree. Oops. It's hard to draw. It's rocking on the... There we go. So let's say that this is 30 degrees. And this length of the shadow over here, that's what the shadow is, over tree. Let's say that that length of the shadow is, I don't know, you take the regular measuring tape and you measure 37 feet. What's the height of the tree? Do we all see a right triangle in the game over here?
Yes. Yes.
Yeah, right? So there is a right triangle through the middle of the tree to the ray going down. That is a right triangle. And now, when you know that your angle is 30 degrees there, what is the name for the 37 side? Is it opposite, adjacent, or hypotenuse?
Opposite.
What was that? Your microphone cut out.
It's the opposite sign, right?
It's touching the angle.
Right? Oh, adjacent. I thought you meant like the opposite side from the angle.
Yes, adjacent. And how about our height?
Hypotenuse.
Hypotenuse cannot be touching the 90 degrees, and we have a 90 degrees right here. Hypotenuse is the longest
Here?
side of the triangle. So it's opposite, yes. Has to be opposite. Good. Now, what trigonometric function out of those 6 connects opposite and adjacent? Which one? Come on. Not a trick question. You have those 6 defined in front of you if you took notes. So which out of those 6 have opposite and adjacent in them?
Tan.
Okay, tangent and the cotangent. Good. All right, so let's use tangent. So tangent theta is opposite over hypotenuse. Let's plug everything in. Tangent of 30 degrees is equal to opposite is unknown over 37. So the height is equal to 37 times tangent 30 degrees. Now, how much was tangent 30 degrees?
Square root of 3 over 3.
Perfect. And now we're going to punch this in our calculator. 37 times square root of 3 close parenthesis divided by 3 is equal to 21 feet. 21.3, but yeah, whatever. It's a tiny tree. That's okay. 21 feet tall. And as you can see, guys, the only thing that you needed there is that 30-degree angle. Now, for that, you need a protractor to measure. And once you are able to measure that, you need a tape measure to measure the shadow. And in good old days, right, when we had normal classes, I used to ask my students to do this measuring on the height of the building they live in, whether it's a house, apartment, it doesn't matter, because they all cast shadow at one point. And you can actually compute the height of the building if you are able to figure out the angle of the sun ray, right? Because that's the one that provides the hypotenuse. Your shadow, right? All this light that is coming from the sun from this side hits the tree, which is why we have the shadow on the ground, because no light passes to light it up. So you see the black shadow because all of the sun rays are blocked by it's either a person or a tree or a building, whatever it is. And then there is this first ray that would make it, which is why there's no more shadow, because every next sun ray that goes this way will hit the ground and illuminate, and there will be no more shadow. So if you are able to figure out the angle of that first ray, right, and that first ray is the one that just barely missed the tree, right? That's why there's no shadow there. You can figure out the height of the tree, height of the building, height of the house, height of the flagpole, like heights of anything, pretty much, as long as you can make the good measurement, right, that you are dealing with, let's say 30. Now, we will learn how to deal with all possible values, not just 30 degrees. You use your calculator, obviously, for it. And we are going to have a few cute problems where we are going to deal with these guys in this way. Now, there is another type where you can set up the proportion, in which case you don't actually need to have the angle, because you will be using trigonometry to set up two triangles, but you have to use, let's say, your own height and the shadow that you will cast. Now, that is another way to figure things out. And let's just put some kind of a building over here. Okay, my building looks like a prison, but that's okay. And again, there will be this ray of light that makes it. I can go steep. Actually, no, that's fine. So that's the first ray of light, and now creates some unknown theta. And this is still your unknown height. But now you don't know the angle at which it hits. You still have the shadow of the building over here. Now, you can, and let's say that shadow is, I don't know, 100 feet. I don't care. It doesn't really matter. Whatever it is. Now, you can write your tangent theta as before, height over 100. But the problem is now that you don't have this theta to compute. Now, this is what you can do. You can take yourself and you can stand, right? Move back and forth until the tip of your head over here lines up with the shadow of the building. That means that your shadow also overlaps there. Now, you know your height. Let's say you are 5 3/4 feet tall, or 5.5. Let's take the average, some average height. Whatever. So 5.5 feet, let's say that's your height. And let's say that your shadow that was casted here is, let's say, 8.2 feet. You measured it. Because anytime you have the shadow on a ground, you can just stretch the measuring tape and measure it. It's not nuclear science there. I mean, even if it's nuclear science, you sit down and you learn it. It's everything. You can learn everything if you care. So now you can write the blue tangent theta, and that's going to be, you are now opposite side, so 5.5 divided by 8.2. And now, look, you have the proportion. So just by inserting yourself into the shadow, right, you can figure out the height of the building. So the height of the building is 550 divided by 8.2. Let's quickly crank that on the calculator because I'm lazy, and we're done. 67.1 feet. The height of the building. Cool. And it's actually good proportion over there that I have in terms of the number of windows, because 67 feet, that should be about 5 stories building. So yeah. Without the roof, right? If the roof is flat, I mean, that's because you have what, 10 feet per floor. Usually ceiling is either 8 or 10 feet. So apartment buildings usually 8 plus the thickness of the floor, so call it 10. So 10 per floor, and a little bit more than 10, maybe 12, right? Because whatever, you have to fit the plumbing, right, through each floor and all that stuff. Anyway, so yeah, this would be about 5-story high building on this height. So that's the part where we can use trig to figure out a lot of cool stuff, as you can see. Now, where did we start? We started by just a regular triangle, right triangle that you know, and we gave it some definitions. And then we define these 6 trigonometric functions, expressions, right? As opposite to the hypotenuse and adjacent to the hypotenuse and so on. Now, this is the part where you actually have to sit down and learn them. So SOHCAHTOA will obviously help a lot. And as I said, you don't get to escape trig ever because it's heavily used in all other courses. So if you don't know this, and I said I used it in my classes today. I actually used it twice in my Calculus 1 class today. So yeah, it comes up a lot. And I hope that you will work hard to figure out the triangle. And no matter which way the triangle is oriented, 2 shorter sides are legs, and the longest side is the hypotenuse. So here is the one that's kind of standing up, but it doesn't matter. The longest side, right, is always opposite of 90-degree angle, and that's the hypotenuse. And then wherever you put the other angle, you have the opposite side and the adjacent side. And you have to, if you want to memorize the SOHCAHTOA, right, that if that helps you, the sine is opposite over hypotenuse and the cosine is adjacent over hypotenuse, right, you can do that as well. Now, the special triangles gave us these cool values, which we are going to now see again from a different perspective in what we call the unit circle. So now we're going to take a break, and then when we come back, we're going to do the unit circle for the same values and talk about angles and all of these trigonometric values from a different perspective. And I'm going to teach you a cool chart of how you can quickly come up with all of these values so you know them. The calculator will never give you the answer, you know, pi over 6 or something like that. And it always spits those decimals out and just looks ugly. So we'll deal with that. Bye.